Everyone. For today's lesson, we are going to continue our discussion about rigid transformations, and we're going to talk about our next transformation, which is called a reflection. And what a reflection is where you take a figure and you flip it across a special line that we call the line of reflection. For today's lesson, you are going to need some colors. You are also going to need a glue stick. You will need scissors for today's lesson, and you should also have all of your cutouts for today ready to go. So you have a few cutouts that you already received, and you will need those to be cut out before you get started with today's lesson. All right, let's go ahead and get started with our learning targets for this lesson. Our learning targets for today are for you to be able to say, I can reflect geometric figures across vertical and horizontal lines, and I can reflect geometric figures across the lines y equals x and y equals negative x. So let's go ahead and take a moment and paste this I can statement directly at the top of our paper. Okay, so let's go ahead and talk really quick about our I can statement before we move on. Our I can statement says that I can reflect geometric figures across vertical and horizontal lines. So vertical lines is something that you graphed when you were in Algebra 1. Vertical lines follow a phrase that I like to call VUX. VUX, V-U-X. And VUX says this, V represents the word vertical line. U represents undefined slope. And X equals a number is the equation for vertical lines. So what you're going to see is X equals a number, and when you graph it, it will be a vertical line. So this is considered the information that you absolutely need to know about vertical lines. So we're going to be graphing vertical lines, and you really want to make sure that you pay attention to whether or not it's X equals or if it's Y equals, because if it's Y equals, those are called horizontal lines. And horizontal lines follows a phrase that we call HOY, H-O-Y, which the O actually represents the number 0. So H-O-Y, HOY, is a horizontal line. 0 is equal to the slope. And instead of an X equals equation, you will have a Y equals a number equation. The line will be horizontal, and it will represent the equation Y is equal to X. Or sorry, Y is equal to a number, not Y equals X. Y equals X is something else. So those are horizontal lines. The other type of lines that we're going to be working with is reflecting geometric figures across the lines Y equals X and Y equals negative X. And they come from, so if I were to talk about Y is equal to X, they are lines that we would write in Y equals MX plus B form. They would be these dashed lines that would go through. So if this was Y equals MX plus B, our B value or our Y-intercept would be at 0. And then we would rise 1, run 1 in order to plot our next point. And we would draw a dashed diagonal line going through those points. So this is the line Y is equal to X. It has positive slope. And it goes through the points 0, 0, and 1, 1. The other line that we're going to be looking at is Y is equal to negative X. for graphing this type of linear function, I'm just going to draw a really quick sketch. We still have our b value. We're still adding a 0. So that means that that's our b value is 0, 0. And now we're going to apply the slope of going down 1 to the right 1. And our dashed line, our reflection line, is going to be, once again, a diagonal line, but it'll have negative slope. So there'll be some with positive slope and some with negative slope. And both of these are what we call diagonal lines. Both of these are diagonal lines. All right, so reflection. What is a reflection? So a reflection is something that you guys are probably familiar with. We look into the mirror all the time, every day, in order for us to get ourselves ready for the day. And what we see when we look in a reflection or look in a mirror is a reflection of ourselves. And so a reflection is simply a transformation that uses a line like a mirror to reflect a figure. So a reflection is a transformation that uses a line like a mirror to reflect a figure. So it uses a line like a mirror to reflect a figure. Now, a mirror line is called the line of reflection. So our mirror line is our line of reflection. Our line of reflection can be vertical, horizontal, or a diagonal. Before we start talking about those specifics, what I would like to do right now is have you guys take out your properties of reflections, of reflection lines. So let's go ahead and talk about these properties. I would like you to please go ahead and paste this cutout, the cutout that has properties of reflection lines, picture, and additional information. Let's go ahead and paste that directly into our notebook. And here are some things that I absolutely need you guys to know. So the first property of reflection lines goes like this. It says, property number 1, if a point is not on the reflection line, we'll call it line M. If it is not on the reflection line, then line M is the perpendicular bisector of segment P prime. Let's go ahead and draw this property. If a point is not on the reflection line, so let's call this point right here letter P. Letter P is not on our reflection line. The reflection of point P across this line is going to be a point that is equidistant on the other side of our reflection line. We'll call it P prime. And we're saying that line M is the perpendicular bisector for the segment P prime. So P was reflected across this line, and this line M is the perpendicular bisector. So let's talk about what perpendicular and bisector means. So this is where additional information comes in. Perpendicular is a word that means that it intersects at a right angle. So notice that when I drew my picture, I drew in a right angle. So that means that there is a right angle that's in between my line of reflection and my segment that connects my points. That is perpendicular. The other word is bisector, and we learned about bisectors before, and a bisector means to cut a segment in half. So we cut a segment in half. So what does that mean? That means that both of these pieces have to be congruent to each other. So it's this point P and point P prime are the same distance away from the line of symmetry. Away from the reflection line. So these 2 points are going to be the same distance away from the line. That is property number 1. Property number 2 says that in the event that a point is on the reflection line, so it's on line M, then P and P prime have to be the same exact point. They equal each other because they are the same point. So if I were to draw a point P, its reflection is also going to be the same point that's on the line. So what that means is that there will be no transformation that is taking place here. So there is no transformation. The point and its reflection is the same exact point. There's nothing for you to count. When you are ready, I have to flip the page and talk about a quick example. So please go ahead and take out this example. It says, use the figure at the right to answer the following questions. So what I'm going to do is glue this directly into my notebook and put it at the top. And this problem says, once again, use the figure at the right to answer the following questions. Letter A says, if point A prime is a reflection of point A, where would the line of reflection be? So if you think about it, it's a perpendicular bisector. So the line of reflection has to be halfway between A and A prime. So it has to be halfway. So what we're going to do is we're going to count how far away is A from A prime. And if I were to count, it looks like it is 1, 2, 3, 4, 5, 6 units away. Half of 6 is 3. So I'm going to count 1, 2, 3. Reflection lines are always drawn as dashed lines. So we always draw it as dashed lines. And if you look, this unit or this point is 1, 2, 3 units away from a line of reflection. And point A is 3 units away from our line of reflection. They are equidistant away. So now the question is, what is the equation of this line of reflection? So an equation for the line of reflection, well, remember that this is a vertical line. So we're going to be working with Vux, V-U-X, vertical line. Vertical line has undefined slope, and it's going to be an x equals a number equation. And where x is, if you were to look at the value of x at any point along this line, it's going to be located at x equals 1. Because if I were to go over 1 from 0, 0, I would land right there on the reflection line. So x equals 1 is our line of reflection. Letter C is asking, if point B were reflected in the same line, where would B prime be? So let's go ahead and plot -4, 5. So I'm going to go over to -4 to the left. So 1, 2, 3, 4, and up 5. 1, 2, 3, 4, 5. It is located right here. Now I want to count your way and see how many points or how far away point B is away from your line of reflection. It is 1, 2, 3, 4, 5 units away. So we're going to count 1, 2, 3, 4, 5 points on the other side, and that's going to represent the location of B prime. Both of these points are 5 units away from our line of reflection. So it is 5 units away from our line of reflection. So let's go ahead and see where B prime is located. So according to this, it says that B prime is going to be located at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So B prime is located at 6, 5. All right, let's go ahead and look at the next one. So the next thing that I would like you guys to do is take out one of your green pieces of paper. So that's exactly what we're going to do. We're going to take out one of our green pieces of paper. And what we're going to do is we're going to take this piece of paper and we're going to fold it in half twice. So fold it in half, going hamburger style, and then we're going to fold it again one more time. So it has been folded twice into a piece of paper that you see here. So folded twice. Then what we're going to do is open it up and we're going to fold it in half one time so that we can clearly see the crease. And we're just going to cut right up the center, just one of the pieces. So I'll show you what that looks like. I am just going to cut it right up so that when you open it up, it has like these tabs. So just one little cut going all the way to the center. All right, let's go ahead and talk about horizontal lines. So I'm going to draw a picture for you down here. And I would like you guys to please go ahead and draw the same. So what I'm drawing is a coordinate plane. We have the y-axis and the x-axis. Let me go ahead and make that clear for you guys. And what I'm going to do is I'm going to draw a horizontal reflection line. So here is my reflection line. And what I'm going to do is I'm going to plot a point that's about right here, and we're going to call it point A. And point A is some x, y value. And what we're going to do is we're going to count so many units up. It's going to be so many units. I'm not sure how many units, but it's going to be so many units up, and I will count this. And then I'm going to identify a point that's about equidistant above it, and I'm going to call it A prime. And what that ordered pair is going to be is that notice that I didn't shift this point left or right. I only moved it up or down. So what's going to happen is that the x value will remain the same, but the y value will become something else. So that's the thing that I want you guys to know is that if you're reflecting across a horizontal line, the x value stays the same, but the y value changes. So that's what I want you to write up here. The x coordinate stays the same. And the y coordinate changes. That means that this is because the point was moved up or down, depending on what we have going on. So this x coordinate stays the same. X stays the same. That's what I want you guys to note. And this is of a horizontal line. Remember that is the line y is equal to some number. So if we were to close this tab would be all about how to reflect across horizontal lines. And remember, they're y equals a number equations. So that's what we would write on the outside. Let's go ahead and talk about vertical lines. Over here, I'm going to draw a similar picture of a coordinate plane. Only this time I'm going to draw a vertical line. And I'm going to plot a point, and we're going to call it point A. And point A is some ordered pair, some xy value. And it's going to be so many units away from our line of reflection that when we count and we plot its reflection point, A prime, its ordered pair is going to have a different x coordinate because I shifted this reflection point left and right. But the y value, because I did not move it up or down, will remain the same. So the y value will remain the same this time whenever you reflect across a vertical line, which remember that is x equals a number. So let's go ahead and write down that information up here. If you reflect across the line that is a vertical line, the x coordinate changes because you are moving left or right. But the y coordinate stays the same. And what's going to go on the outside of this one, so it's x coordinate changes, the y, because we're shifting this point left or right, but the y coordinate stays the same because we are not moving this point up or down. So now we are on, I'm going to write on the outside that this is all about vertical lines. And this is x equals a number. When you are ready, please go ahead and paste this directly into your notebook. Our last cutout, we're going to be doing the exact same thing that we did before. So we are going to be folding it in half, as you see right here, and then folding your piece of paper in half again, opening your paper back up, and folding it back in half, hot dog style, so you see it like this. And now you see the crease, and we're only going to cut it up to the middle on one side, just one piece gets cut. So now what you see here is a lovely little tab. And now we're going to be talking about those diagonal lines. So the diagonal line that we're first going to talk about, which I'm actually going to write on the outside that this is a reflection over the line y is equal to x. And this is the coordinate rule. That we're going to be identifying. So the coordinate rule is, if I were to draw, it would be this. So our coordinate rule, I'm going to write down right here, is going to be our x, y, our ordered pairs, change into simply y comma x. So essentially you're going to switch the order of x and y. And that is your rule that you will follow. So in the event that you are reflecting across a diagonal line of y equals x, and I'll draw a picture for you in just a second, the rule that you will follow is that xy changes into, remember that arrow means changes into, y comma x. So what that looks like is this. I'm going to draw a coordinate plane, and I'm going to sketch the reflection line of y equals x. So remember that y equals x, that has a vertex, it has a y-intercept at 0, 0. And then I'm going to rise one, run one, and draw a dashed line going through these points. That is my reflection line. And so if I were to plot a point, and I were to call it point A is going to be so many units away, but it's going to be on a diagonal. So when you count on the other side to find where A prime is, you can't count because it's going to be like on a diagonal. But what we find is that your ordered pair of x, y, so let's say that we're going over 2 up 4, for example. If I were to go over 4 and up 2, I would land at the reflection point. So this reflection is going to be where I flip-flop x and y, and this becomes y comma x. We flip-flop or switch the order of x and y, and that's how we come up with our points of reflection. All right, let's go ahead and move on to the next one. This is a reflection over the line y equals the opposite of x, or negative x. And we're going to identify the coordinate rule. Let's go ahead and open this up. So let's go ahead, let me give you the coordinate rule first, and then we'll talk about it. The coordinate rule is x, y, or your ordered pairs, change into, instead of just y comma x, where you're flip-flopping x and y, both of the signs will be opposite signs. So these negative doesn't mean that it automatically turns negative. Instead, these negatives indicate the opposite sign of. So they become opposite signs, negative. So if x was negative, it becomes positive over here. If y was positive, it becomes negative over here. The signs become opposite. Opposite signs. So you switch the order and switch the sign. So you switch the order and the sign. All right, let me show you what that looks like up here with a picture. So in my picture, I'm going to draw a coordinate plane. And this time around, I'm going to write in the equation y is equal to negative x, and I'm going to draw that reflection line. So we plot it at 0, 0, and then my slope is -1, so I go down 1 to the right 1. And now I'm going to draw a dashed reflection line of y is equal to negative x. So it's going to be a dashed reflection line. And I'm going to plot a point, and we're going to call it point A. And point A is located at some x, y value. Its reflection point needs to be equidistant on the other side from the line of reflection. And we're going to call it A prime. And if you think about it, let's say that this was located at 2, 3. All right, so we're talking about this being at 2, 3. If this was located at 2, 3, and we're using the coordinate rule, that means I'm going to go over -3 down -2. So this would be opposite of y, comma, opposite of x. So we would go to the right -3 and down -2. So that is what it would look like. And that's how you would use the rule. I'm going to go ahead and fold that over and paste this directly into my notebook. And that is at the end of today's lesson. If you have any questions over anything that I talked about in this lesson, please feel free to email me. Otherwise, I hope you have an awesome day.